Hello, my name is Ali Pournaghdali, and this is a pre-recorded presentation for the 2020 meeting of the Society for Mathematical Psychology. Here, I will present a project that I conducted under supervision of my advisors, Bennett Schwartz and Fabian Soto. To investigate the possibility of non-conscious perception, a standard practice in the field of consciousness research is to contrast performance in a perceptual discrimination task, such as two alternative force choice tasks, against chance level only in the trials that participants report not being aware of the target. Higher than chance performance in such trials represents non-conscious perception. Two unwanted factors may play a role in the observed non-conscious effect resulting from this approach: regression to mean and conservative criterion. Therefore, a new type of analysis is needed to evaluate conscious and non-conscious perception with more accuracy. Here, I present a novel model-based analysis of data within the framework of general recognition theory, or GRT, for experiments gathering subjective reports of awareness and perceptual discrimination within each trial. To this end, we ask participants to do two tasks: a subjective awareness task with at least two levels, a stimulus present and a stimulus absent, and a perceptual discrimination between two levels of perceptual dimension, for example, fearful versus neutral facial expression. Next, we feed the data to a two-dimensional GRT model, with the y-axis being awareness and the x-axis being discriminated stimulus value, for example, facial expression. Each stimulus in this model is represented by a two-dimensional normal distribution depicted through an ellipse in the figure. The two stimuli are represented by distributions higher in awareness and away from zero in opposite directions along the x-axis, corresponding to opposite expressions. Trials with no stimulus are represented by a noise-only distribution centered at zero in both dimensions. After fitting the GRT model to data, we use the estimated parameters to construct a sensitivity versus awareness curve, or SVA curve for short. As you can see in the right graph, the y-axis in an SVA curve represents sensitivity in the perceptual discrimination task conditional to a specific value of awareness, represented by the vertical dotted line in the GRT model. The x-axis represents the relative likelihood of no awareness for that same value of awareness. As we move from top to bottom in the awareness axis of the GRT model, the relative likelihood of no awareness increases. Each point on an SVA curve represents conditional sensitivity at each level of relative likelihood of no awareness. An interesting element in an SVA curve is the objective criterion based on the optimal observer, which is a point in the x-axis where the likelihood of awareness equals the likelihood of no awareness. The objective criterion divides the x-axis into two areas, the areas of high and low likelihood of awareness. The pattern of an SVA curve allows us to determine whether perceptual processing in the discrimination task depends on awareness. Higher than chance sensitivity in the area of high likelihood of awareness represents conscious perception of the target stimulus. Higher than chance sensitivity in the area of low likelihood of awareness represents non-conscious perception of the target stimulus. We use this model-based analysis to investigate the possibility of non-conscious facial expression recognition under the influence of continuous flash suppression, or CFS. In two experiments, we rendered fearful and neutral faces invisible using CFS for 500 and 700 milliseconds. In each trial, we asked participants to perform yes-no detection task as the measure of awareness, to classify the emotion of the faces in the discrimination task, and to rate their confidence in their discrimination accuracy. In catch trials, we presented no stimulus. In each experiment, we feed two GRT models to the data and created two SVA curves, an SVA curve for the discrimination responses and an SVA curve for the metacognitive confidence ratings. Here we show SVA curves with their 95% confidence intervals for the two experiments. In both cases, discrimination ability of participants depended on awareness. As the likelihood of being aware of the stimulus dropped, so did the discrimination sensitivity. The discrimination sensitivity reached zero after the objective criterion and in the area of low likelihood of awareness. This indicates that facial expression recognition happens in the absence of awareness when using CFS. The SVA curves resulting from confidence ratings also showed a similar pattern and indicated the survival of metacognitive processes in the absence of awareness when using CFS. Thank you for your attention.